let's take a look at radical functions here in this section. So radical functions are functions with radicals in it, basically, right? So I'm talking about the square root function, the cube root function, and so on, right? And let's talk about finding the range and domain for these types of functions here. Let's start with real simple. Let's start with the square root function. Let's consider f of x equal to the square root of x. Real simple here. All right. So let's go ahead and graph it. But also find the domain and range. Then find domain plus range. All right. Find domain and range. Well, now, domain is what? Domain is what x can be. What can I plug in for x? Well, if you recall, we can't take the square root of a negative number because that's not a real number, right? So, therefore, we have to make sure that x is not a negative number. So, the domain, we can say that for domain, we have to make sure that whatever's inside the radical is greater than or equal to what? 0. Because if it's negative, then take the square root of it, you get an error on the calculator, or because it's not a real number. But square root of 0 is 0, square root of 1 is 1, and so on. So that's fine. So domain for a square root function will be what? 0 or bigger, right? Now to write that in set builder notation, then it'll be what? All real numbers x, such that x is greater than or equal to 0. Right? In interval notation, it'll be what? Interval notation, it'll be from 0 to what? Infinity, right? So again, know how to write the notations in either set builder or interval, as we've done in the past, right? No big deal. But again, the key concept is what? For a square root function, we cannot take the square root of a negative number since that's not a real number. So we have to make sure that whatever's inside the square root should be bigger than or equal to 0. Okay, more on this later, right? But let's go ahead and to find the range. Before we do that, it's best to get the graph. So graph first before you find the range. Right? So let's go ahead and make a table of values here. Let's make a table of domain values x and function values by plugging it into this simple square root function. So again, as I mentioned, we need to pick x to be what? 0 or bigger, nothing smaller than 0. So 0 here, what's the square root of 0? Well, certainly 0. Pick 1. Square root of 1 is what? 1. Now don't pick 2 because 2, the square root of that's fine to plug it in, but that's going to be a decimal. Let's try to pick the x carefully so that the square root of it is an integer. In other words, it's best to pick what? The next x. Well, how about 4? Because the square root of 4 is what? If I plug it in, 2. Can we see that? So again, pick nice numbers for x so that when you plug into the function, you get a nice number for y, or the function value. All right? It's easier to graph that way. So next one would be, I'll do one more, it's going to be 9 because these numbers are getting big in a hurry since we're taking the square root of it. And that's going to be what? 3, obviously. All right. So we have 4 points to locate. Let's see what the sketch of the graph looks like. All right. So here's y, and here's x. All right. So 1, 2, and 3. 1, 2, and 3. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Go all the way out to 9 there. All right. So again, 0, 0, 1, 1. 4, 2, 1, 2, 3, 4, and 2 there, and 9 all the way up to 3. So the graph looks something like this. So this is the sketch of the square root graph. Okay, roughly the sketch of the square root graph. Okay, so this is the graph of f of x. As you can see, then we can now find the range, because the range is what y values the function takes on. Now from my table, you can see that the y values are either 0, 1, 2, 3, and so on, 0 or what? Or bigger. And from the graph you can see that as well, right? That there's no graph down here, so therefore the range is going to be what? 0 or what? Or greater. Okay? So the range then from this picture is going to be y greater than or equal to 0. Again, set builder notation, then we say all values, all real numbers y such that y is greater than or equal to 0. 0 right there. Sorry about that. Sketchpad acting up there. All right. So set builder notation. Know how to use interval notation as well, but that's not a big deal. Okay. Let's look at another one. Let me go and clear out the screen. Let's look at the cube root function. take a look at g of x and equal to the cube root of x this time, cube root this time, right? And let's go and do the same thing. Let's go and graph it and also find the range and domain. Right? Let's start with the domain values. Domain. Again, this is cube root, right? So the only thing in question now for square root, what? We can't make x negative because we cannot take the square root of a negative number. But what about a cube root? Well, for example, let's look at the cube root of -1. Is it okay to take the cube root of a negative number? Well, yes, it is. If we punch out to the calculator using the cube root feature, for example, then we're going to get -1 because -1 cubed is -1. That's the reason for that. Right? Likewise, cube root of what? -8. What's that? Because -2 cubed is -8, then the cube root of that is -2. In other words, all I'm saying here is what? That it's okay to plug in negative numbers for x, as well as positive numbers, of course. So therefore, there are no restrictions on the domain when it comes to the cube root function. So the domain is going to be all real numbers. Domain is all real numbers. And you can write that in the interval notation, -infinity to infinity. All right? All real numbers for domain. So again, no restrictions for a cube root function on domain, because we can plug in positive numbers for x, obviously that's true, but also negative numbers can be plugged in for x and be taking the cube root of it too to get these values. Now to graph it though, that's going to be a little bit tricky, because look at the table I'm going to do here, right? Function x values and function values, domain and the range. All right, so a little bit more tricky now. Pick x very carefully. Let's pick x to be 0. What's the cube root of 0? Well, that's going to be 0, obviously. Pick x to be 1. Cube root of 1 is going to be 1. All right. Let's pick x to be. Don't pick 2 now again, right? Don't pick 4, because cube root of 4 is not a nice number, so it's going to be decimal, right? We should pick what? 8 next. 8 there, all right? So because the cube root of 8, it's going to be what? 2. Let's pick the here are the two negative values I had for you earlier, right? -1, cube root of that is going to be -1. -8, cube root of that is going to be what? -2, as I had up there. All right. Let's take a look at the graph of this function roughly, right? So let me go and get the graph here. So a little bit tricky here, but we can work our way around it a little bit. So let's see, 2, 3, 1, 2, and 3. But I need to go out to -8 for x and +8 for x. So 1, 2, 3, 4, 5, 6, 7, 8. Here's -8. This one right here, namely, and +8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So again, let's plot these values: 0, 0, 1, 1. Okay, this graph's a little bit different now. 8 and 2. 8 out here, 2 up here. Sorry, my graph is not completely in good shape here, but you get the idea. I'm just plotting these points: -1, -1, and -8, -2. -8, -2 is down here. So the graph is going to look something like this here. Let me go ahead and sketch it. It's pretty tricky here. Let me on the sketch pad, but I'll do the best I can. All right. So that's what it looks like roughly here on the sketch pad. But basically, it's this curve right here. All right, and so therefore, that's what the cube root function looks like. All right. Now, what is the range then? Well, let's take a look at the range. As you can see, we can have what? Look at the y values here. We can have positive numbers as well as what? Negative numbers. So the range would be what? All real numbers again. So for the cube root function, we can see that not only domain is all real numbers, so is the range. All right. Now, how do we write that in set builder notation? Earlier we had that, right? So we say all real numbers x such that x, this little epsilon symbol, means is a real number. All right. This is the set builder notation for all real numbers. All right. But my point is what? For a cube root function, then we have range and domain being all real numbers. All right. Now, let's go ahead and come to some generalization then, right? So let me go and clear up the screen. Let's take a look at the function f of x equal to the nth root of x, all right? So earlier, when we had the square root function, the index here is 2, right, for square root. and we have to make sure that this number is never negative. Otherwise, it's going to be not a real number if it is, right? Now, for a cube root function, when this index is 3, then it's okay for x to be negative, right? And the domain was what? All real numbers. So we can now come to a conclusion based on that discussion from the two earlier examples that if n is even, if the root index is even, then this has to be a number that's not negative. If the root index is odd, such as the cube root function, this number x could be anything or all real numbers. So we can say this. We can say if n is even, then domain is going to be what? Domain is going to be all numbers bigger than or equal to 0. So we have to make sure we're not taking the nth root of a negative number if n is even, if the root index is even, such as 4, 6, and so on. Right? However, if n is odd, if the root index is odd, then a domain is going to be what? All real numbers. Alright, all real numbers. So no restriction on domain if this is odd, such as cube root we had earlier. Alright? So n could be 5, 7, 9, whatever, then domain is what? All real numbers. Alright? Alright, so let's go ahead and so we have this generalization for domain. Alright? Let's go and try a few more functions in terms of finding the domain of them. And let's go and graph a few more as well. Alright? So let's go and try this one. Let's take a look at this function here. F of x equal to, let's say, the let's make it the square root function again. Let's make it, well, how about fourth root? Fourth root, so root index is 4 here, right? Fourth root of x minus 2. Alright? So now I don't want you to graph this. I just want you to find the domain. Find domain only. And use either notation, set builder or what? Interval notation. So let's find the domain. Again, check with the root index. It's 4. That means what? It's even. So we have to make sure this criteria right here. Right? In other words, we have to make sure that whatever's inside the radical here, in this case x minus 2, must be what? Greater than or equal to 0, because that can't be negative. And you can't take the fourth root of a negative number. All right? Similar to square root then, right? So if I were to solve that very, very quickly, then you see that x has to be bigger than or equal to 2. So domain here is going to be all real numbers x such that x is greater than or equal to 2. If I use set builder notation, if I use interval notation, it will be bracket on 2 to infinity. Okay? So no big deal. Either notation is fine. All right? But again, if the root index is even, we need to make sure the inside, the radicand, right, whatever's inside the radicand, is always bigger than or equal to what? 0. Okay? Let's try another one. Let me go and clear out the screen. Let's say g of x is equal to the cube root. Well, let's make it the 7th root of 6x plus 12. Okay? Again, just find the domain. Do not graph. Just find domain only. But again, this root index is what? Odd this time, so no restrictions on x. Right? If the root index is odd, so therefore domain is what? All real numbers. Alright? Negative infinity to infinity. So really there's no work to show if the root index is odd. If the root index is even, then we have to do some work. So here's what I mean by that. Let's go ahead and take a look at this one here. H of x equal to, let's say, the, let me go and put it this way. Let's go ahead and write something like 15 minus 7 times the quantity 2x minus 1 to the 1/6 power. Right, to the 1/6 power this time. Alright? And let's go and find the domain of this function. Again, just find a domain. Right? Now again, here you have to figure out the radical notation for this fractional exponent then. Right? But that's not too hard, as we saw earlier. This is just the 6th root of 2x minus 1, right? So in other words, we could rewrite h of x as 15 minus 7 times the 6th root. 1/6 means 6th root of 2x minus 1. Therefore, the root, again, ignore the 15 and the 7, basically, right? Look at the root index right here. It's 6. That means what? It's even. Right? Which means what? We have to make sure that this radicand, 2x minus 1, must be what? Greater than or equal to 0, because you cannot take an even root index of a negative number. Alright? That's not a real number. So let's go ahead and quickly solve that. That's not too hard to solve, as you can see. 2 there. Let me cross it off. Sketchpad's acting up. 2x greater than or equal to 1. X greater than or equal to divide by 2. 1/2, as you can see, right? And again, you could write that in the set builder. X such that all real numbers, x is going to be greater than or equal to 1/2. Alright? No big deal. Let's go and try a couple more, and then we'll finish off with some more graphing here. Let's take a look at f of x. F of x, make it equal to, let's say, 3x plus 2 times the quantity, let's say, let's make it, let's see here, let's make it, let's see here, 7 minus 3x. All that to the, let's take that to the, oops, come on, sketch pads. It's acting up on me a little bit. Take that to the 1/12 power, alright? But again, there's your root index, right? So you could rewrite this as, so you could rewrite f of x if you wanted to then. Again, find domain. I should say find D for domain, alright? So you could rewrite f of x, if you will, as what? 3x plus 2 times what? Plus 2 times the 12 root, right? 12 root of 7 minus 3x. The key is to figure out the root index once again. So it's 12, it's even, right? That means what? 7 minus 3x, whatever's inside, in this case the radicand of 7 minus 3x must be bigger than or equal to 0. Not a big deal there, right? And we can certainly solve that. Let's go ahead and subtract 7 on both sides. Not too bad. Negative 3x greater than or equal to negative 7. Divide by negative 3. So I need to what? Switch the direction of the inequality since I'm dividing by a negative number. So x will be less than or equal to positive 7/3. Alright? Positive 7/3. So negatives divide out. So again, how do we write that? In the set builder, all real numbers x such that x, oops, my sketchpad's acting up on me here. Let me slow down a little bit. It's x right there is less than or equal to 7/3. Alright? And how about interval notation real quickly? That's going to be negative infinity, alright, up to what? 7/3, including 7/3. Alright, so again, know both notations obviously. But again, the key is what? Figure out the root index. It's even. Then set that inside quantity here, inside the radicand to bigger than or equal to 0, and finish solving it. Alright, easy problem to solve. If the root index is odd, so if I say, I'm going to clear out the screen here. Real quickly, if I give you something like this, h of x equal to 9x cubed plus 5x minus let's say the quantity x minus 1 to the, let's make it 1/9 power, right? Then again, just ignore this stuff here. Just look at this root index being 9. So this is really the 9th root, right, of x minus 1, which is what? Odd. So therefore domain is going to be all real numbers. There's really no work to show in that situation, right? So not too bad at all. Again, key is the root index, right? If it's odd, automatically all real numbers for domain. If it's even, we have to do some work. Set the inside bigger than or equal to 0, and finish and write the appropriate notation for it. All right. Anyways, let's go ahead and do another graph here to finish out, if you will. Here. Let's go ahead and let's graph this one. Let's graph f of x. F of x equal to, let's say, square root of x minus 1 plus 3. Okay, so 3 is outside the square root this time. Let's go and graph this. But again, to graph this though, I need to find the domain first, right? So again, this is square root. So that means what? Root index is what? 2, right? Invisible 2 here. So I have to make sure that x minus 1 is bigger than or equal to 0, as you may suspect. So x is greater than or equal to what? 1 if I add 1 to both sides. So in other words, if I'm making my table here of x values and function values, then I need to make sure I pick x to be 1 or bigger, nothing less than 1, in other words, right? Okay, let's just pick out some numbers here. 1 for x, 1 minus 1 is what? 0. So plug it in, so you get square root of 1 minus 1 plus 3. This is going to be what? 0 plus 3 or just 3. What's another one for x? Well, don't pick 2 because, well, I can pick 2. 2 minus 1 is 1, which is a perfect square, so which is good. Actually, pick 2 then. So square root of what? 2 minus 1 plus 3. This is root 1, right? 2 minus 1 is 1, right? Plus 3. So this is going to be 1 plus 3, or 4. Right? No big deal there. Let's pick, what's the next choice for x? Or how about 5? Right? Because 5 minus 1 is 4, which is a perfect square. So again, you want to get a perfect square inside, right? So think about what to pick for x carefully here. So square root of what? 5 minus 1, let me show you the work again, plus 3. So this is going to be square root of 4 plus 3. That's a 3 right there, sorry about that. Which is what? Root 4 is what? 2 plus 3. So that's going to be 5. Alright, again, you get the next. You get the idea. The next one to pick then would be what? Would be probably 10, right? So 10, because you plug 10 in, you get 10 minus 1 is 9. Root 9 is what? 3, and so you get 3 plus 3. You get what? You get 6 in that case, right? But again, I'm not going to work the rest of it out. You get the idea here. But let's go and graph the function here. See what it looks like here. So here's y. Here's x. Okay, sorry about that, guys. Let's see here. I have to go up to 5 here. 1, 2, 3, 4, 5 for my y value, and go up to 5 as well for x if you don't mind. 1, 2, 3, 4, 5. All right, so we have 1, 3. So 1, 3. There it is. 2, 4, 2, 4, and 5, 5. 5, 5 is right here. So the sketch of the graph looks something like that. Oops, missed it a little bit. But you get the idea. All right, but now let's figure out the range. So the domain. This is domain, right? And again, know how to write the appropriate notation for that, right? Let's look at the range, right? R for range. As you can see that from my table as well as from my graph, there's no graph below the y value of 3. This is y value of 3, right? So nothing down here. So the range is what? 3 or what? Greater, as you can see. Alright, so from the picture you can see that the possible y values for this function is 3, 4, 5, and so on, bigger. Alright, so y greater than or equal to 3. Okay, again, know how to use the appropriate notation. All real numbers y such that y is greater than or equal to 3. Alright, so again, that's set builder notation for that. Okay, so again, graph these functions carefully by picking x carefully to figure out the y values there, and get the range as well once you get the graph. All right, so let's go ahead and finish up with a couple of problems for you then in terms of this section. Let's go and clear off the screen. All right, so here's a couple of problems we're posing to Blackboard then. All right, so let's say this function. I give you a function such as f of x equal to 9x plus let's make it 5 times the quantity. Let's make it 5 times the quantity. Let's make it. Let's see here. 4 minus 3x. All that to the 1/4 power. All right. I just want you to find the domain. Find domain in interval notation. Just use interval notation. In interval notation. Interval notation. All right. Now, if you can't find the infinity symbol on your computer, just write the word infinity, for example. That's fine. So, for example, if the domain is let's suppose the domain is, let's say, x greater than or equal to 0. Let's say, right? That's not the answer here, but let's say that's the case. So how do we post that into Blackboard here? Well, in interval notation, it'd be what? Bracket 0 to infinity, right? But you can't find the symbol infinity on your computer. If you can find it, great. If not, then just write the word. Just write in infinity. Then I'll understand. Or negative infinity if it's negative infinity. All right. So just do it that way on Blackboard, and I'll understand it. All right. Anyways, find a domain for this function in interval notation. All right. Post that into Blackboard. And number 2, let's go ahead and find the domain and range for this function. So suppose I give you this function of let's see here. How about let's see here. How about let's try the square root of x plus 2 minus 1. All right. Let's go ahead and find the domain and range. Domain and range. You might want to graph it as well, but I'm not asking you for the graph here. Just find the domain and range in interval notation again. In interval notation, and post it into Blackboard. Alright, so there we have it, right? So there's the square root function to find the domain and range. There is the fourth root function in this case, right? 1/4 to find the domain only, and post it in interval notation into Blackboard again. Just use the word infinity for the symbol infinity if you can't find it on the computer or in Blackboard. Alright, so we'll go over in class then. Until next time.